Hello and welcome back. Today we're going to talk about scientific notation. Scientific notation is a way that we can express numbers, very large or very small numbers, in a simplified form. So we reduce the number of zeros in very large and very small numbers, and we do this by multiplying our number by a power of 10. Rules for scientific notation: you can only have one digit in front of the decimal place. So the number's got to be between 1 and 1 and 10. So 1 point something up to 9 point something, and then you will multiply it times 10 to a power to move the decimal point. For example, 10 to the third is the same as times 1,000. 10 to the second is times 100. 10 to the first. So there's 1,000. Whoa, that's really big. Let's undo that. Make this a little bit smaller. So 10 to the third is times 1,000, second is 100, first is 10. Then we go negatives. 10 to the negative first is 0.1, so we move the decimal 1 to the left. So we look at this. 10 to the first is the same as 1 times 10. We slid the decimal over to there. 10 to the second, we took 1, and times 2 means we moved it twice. 1,000 means we moved it 1, 2, 3 times. Going the other way, we have 10 to the negative first, taking this decimal going back to the left one because it's a negative sign. Negative second goes over twice. Negative third goes over 3 times. This is scientific notation. Very large numbers. So for example, 4 trillion, 500 billion. We can change and we can make, so put the decimal between the 4 and the 5 to make this number between 1 and 10. So 4.5 is going to be our number. And then we move it back to where it started. And so we moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places. So any big number, and big being bigger than 10, is going to have a positive exponent. For small numbers, for example, 0.0015 kilograms. If we put our decimal here between 1 and 5 to make it between 1 and 10, and we move it. So we go 1, 2, 3 places to the left. Because we went back to the left, we got a smaller number than 1. And so we have 1.5 times 10 to the negative third kilograms. For a shortcut, you move the decimal point and count the number of places you move it to get the number back in front of the decimal. Oops, skip the space. So here's a chance for you to practice. So 800 million meters, 0.0000284 kiloliters, 4.5 times 10 to the third grams, and 1.99 times 10 to the minus 8 centigrams. If you want to pause this page and try those on your notes, that'd be fantastic. I'm going to keep going because we have one more little bit to cover. The last thing is we can do math with scientific notation. So when you multiply numbers, using scientific notation, we add the exponents. So you do the multiplication and then you add your exponents. When you divide your numbers, we then subtract the exponents because it is divided. So we're getting smaller there. So for example, if we have 5.5 times 10 to the fourth centimeters times 1.4 times 10 to the fourth centimeters. We're going to take 5.5 times 1.4, which is you see here. We're going to add 4 and the 4, because those are my two exponents. So times 10 to the 4 plus 4. So we're going to take 5.5 times 1.4 and get 7.7 times 10. And then we know that 4 plus 4 is 8, so there's 10 to the 8th. And because I took centimeters and multiplied it by centimeters, I have 2 of them, so there's centimeters squared. So that would be if we were to find the area of something, that could be our unit there. If we divide numbers, again, we subtract exponents. So for example, 6.05 times 10 to the 7th grams divided by 8.8 times 10 to the 6th cubic centimeters. So 6.05 divided by 8.8, which gives us a number that is we divide those two, we get 0.6875. So down here, I'm going to write 0.687. Darn it. 6875. So here's my 5. And then I had 10 to the 7th here, and 10 to the 6th here. And so 7 minus 6 is 1. So this is going to be times 10 to the 1st. And because I did that, remember I have to make this number between 1 and 10. Got to be between 1 and 10. To do that, I'm going to move my decimal one place over to there. So it's going to be 6 point, and we're going to talk about significant figures here in a little bit. So using this, we have 2 significant digits, so we're going to round to two numbers. So 7 here rounds the 8 up to a 9, so we have 6.9. And then, because that's my number, it's between 1 and 10, I moved it anyway. So because I moved it this way 1, I can take off the times 10 to the 1st, but I still need to write 6.9 times 10 to the 0 grams per cubic centimeter. If you're doing scientific notation, even if it's here, and you don't have to you don't need a number, you have to write times 10 to the 0. You cannot just write 6.9. Because I'm asking scientific notation, you have to have the times 10. Alright. Here's a chance for you to practice. 1.08 times 10 to the minus 3rd multiplied by 9.3 times 10 to the minus 3rd. For the first one, and then the second one is 5.4 divided by times 10 to the minus 1 divided by 3.4 times 10 to the 1st. So I'll have you practice those on your own. When you get answers, you can sure send them to me and check and see if you got it right. Until next time, best of luck, and I will talk to you later.